Hi, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying quadratic relations. In this video, we're going to look at the vertex form of a quadratic, and it's not really a teaching video, it's just going through some practice material that I gave my students in preparation for a summative evaluation. So let's very quickly look at what we mean by the vertex form of a quadratic. So this is what it looks like. You should recognize A, H, and K. That's a quadratic in vertex form. We call it vertex form because, of course, the vertex is very easy to find. You know what H and K are from the diagram, from the equation given, and you just have to write the vertex, remembering that this minus sign plays a special role. And the value of A, well, that tells us the same thing that A always does, which is the shape of the quadratic. Specifically, if A is greater than 0, it opens up and therefore has a minimum. If A is less than 0, it opens down and therefore has a maximum. And of course, the value of A tells us if the shape is very narrow, meaning it has been stretched, or if it's very wide, meaning that it has been compressed. So let's just jump into it. This is the question that I'm going to be taking up in this video. Feel free to pause the video now if you haven't seen this question. Try this on your own and then come back and join me as I take it up. So let's jump into it. Here again is that equation. And first we have to find vertex and axis of symmetry. Of course, these two concepts are always related because the axis of symmetry is a vertical line that has the equation x equals something, and that something is always h from the vertex. So if you know the vertex, you know the axis of symmetry. And if you know the axis of symmetry, you know the first coordinate of your vertex. So when I look here at this equation, I can see that the vertex is -3, 24. So again, why is it -3, not +3? Well, just a reminder that, one second. Yay. That when you have the vertex equation, the reason why this negative sign is here is to remind you that the sign you see within the bracket is the opposite of the sign that you want. So that's a quick memory trick. I mean, more importantly, it's probably better to just quickly discuss that the reason why -3 is so important is because -3 is the value of that if I sub in for x would make this bracket 0. And 0 squared is important because if I had, say, 2 squared, the answer is 4. Well, so is -2 squared. Oops. If I had 5 squared, that would be 25. Well, so is -5 squared. So that's why there's symmetry in every parabola, or every quadratic relation, but 0 squared, there isn't another number that also gives me an answer of 0, which is why there's no symmetry when the bracket is 0. And if there's no symmetry, the only point on the parabola that has no symmetrical point is the vertex. So again, whatever tool you use to remember that the vertex is here and here, you just have to remember to change that sign. And if we know the vertex, we automatically know that the axis of symmetry is the vertical line at x equals -3 because it's always the same value as the x coordinate of the vertex. Okay, so what do we have to do next? Now we need to find the y-intercept. So finding a y-intercept, no matter which grade of math you're in, if you have an x-y relationship, finding a y-intercept is always found by letting x equal 0. And then we'll do whatever math we can. So I'm going to substitute 0 in for x. And then I'm just going to use my algebra order of operations skills to find the value. So 0 plus 3, do the bracket first, is 3. And then I have an exponent to do. So 3 squared is 9. There's multiplication, -2 times 9. And then finally, the addition, -18 plus 24 is 6. So just reminder, please don't leave your answer like this, because y equals 6 is technically a line that is horizontal. So you should answer as a point because a y-intercept is a point. So x is 0 and y is 6, so that's the y-intercept. Okay, next question. Now I need to find, oh, I caught myself. I said x-intercept, this is the y-intercept. Because now I have to find the x-intercept. And the method is to let y equal 0 and then try to solve for x. So we're going to substitute 0 in for y, and then again do some good algebra to solve for x. So it's more than order of operations because we're actually solving. So that means we need to isolate this x term. So we're going to be undoing all of the math that's protecting that x. So we're, in a way, we're working from the outside in. So first, I'm going to get rid of positive 24. And to remove it, I subtract 24 from both sides. Then I need to get rid of negative 2 because negative 2 is further away algebraically from the x. So dividing both sides by negative 2. And now I need to take the square root of 12. And here, really important, don't forget, when you take the square root of a number, your calculator will say one answer, like 3.5, but you have to remember that there's another answer, which is negative 3.5. So there's two answers to the square root of 12, and that's what's going to give me the two x-intercepts. So again, I took the square root of both sides. So here the square root of 12 is 3.5 or negative 3.5. And here by square rooting, I just remove the square. So finishing off, subtract 3 and subtract 3. So there's my answers, but again, x-intercepts are points, so we need to write them as points. So there's one x-intercept at here, and the other x-intercept is here. Okay, next question. Oh, I did want to put a warning here. Don't forget that at this point in my math, if I had a negative number here and I was about to take the square root, I can't. You cannot take the square root of a negative number. So therefore, you would have said that there are no roots, no x-intercepts, which can happen if your parabola looks like this, or maybe it looks like this, right? Or perhaps it looks like this. So if your parabola opens up, but the vertex is above the x-axis, or if your parabola opens down, but your vertex is below the x-axis, you're not going to get x-intercepts. That's why sometimes this impossible math tries to happen, and you just have to be careful to not confuse the issue. You can't take the square root of a negative, at least not in the real number system, and that's what we're working on. Okay, what's next? Now I need to find y when x equals 5. So this is just simply substitute and solve, or substitute and evaluate. So I need to let x equal 5 and do some math. So substituting 5 in for x, and then it's just order of operations. So inside the bracket, 5 plus 3 is 8. Then I have an exponent, 8 squared is 64. Then I have multiplication. Negative 2 times 64 is negative 128. Oh, sorry. Negative 128. And then finally the addition and subtraction level. I get negative 104. So when x is 5, y is negative 104. A better way of expressing that is to write it as a point. All right, next question. Now, same idea, we need to find x when y is this number, so we're going to sub in this number and then do the math to find x. So y is negative 74. I sub that in for y, and then x can hopefully be solved for. So again, there's my x. So in solving, I need to remove the things that are furthest away first. You know, in class I say kill the king, and those are the bodyguards. So the first bodyguard I can encounter is the plus 24, so I'm going to subtract 24 from both sides. So subtracting 24 from both sides gives me this. Then divide both sides by -2. And now I'm ready to take the square root. So when you take the square root, excuse me, you get two answers. So the square root of 49 is either 7 or -7. So one equation looks like this, and the other equation, oops, looks like this. So the square root of 49 is 7, and the other side is x plus 2. Or the square root of 49 is -7, and the other side is x plus 2. So on both sides, subtract 2. And then now I know that there are two possible answers when y is -74, and a better way to write my answer is to write it as a point. Okay, what's next? Okay, so now I need to rearrange into standard form. So remember that standard form looks like this. So it is the expand and simplify result of a quadratic relationship. So I need to expand this and then collect like terms by simplification. So following the order of operations, inside the bracket, I can't do x plus 3 because x and 3, I can't collect them together. So then I have an exponent. So I'm going to do the exponent. So squaring a binomial, square the first, double the product. The product is positive 3x. If I double that, I have positive 6x. Square the last, positive 9. So I did the exponent. I still can't do anything inside the bracket. I can't collect like terms. No more exponents. Well, here, but I can't do anything. So multiplication. There's multiplying -2 times the bracket. So that's next. So -2x squared minus 12x minus 18. And finally, I can collect like terms because those are both constants, meaning they're terms that don't have an x. So they're like terms. -18 plus 24 is positive 6. So this is in standard form. I wonder if you can see that my malware is out of date. Please don't send me any viruses until I fix it or get a better virus program. So there, that is in standard form. And by the way, in standard form, look what we can see. Remember, in standard form, this is the y-intercept. And if we go back, we knew that the y-intercept was at 6. So it's kind of nice to see our math telling us we're probably on the right track. And then finally, we need to draw the graph. So here are some good things that I know that I'm probably going to use to put on my graph. So we found that the vertex was -324. Axis of symmetry, we know where that is. So the AOS is at x equals -3. We have the y-intercept at 0.6. The x-intercepts were at 0.50 and -6.50. I also have a point at 5, -104, but that's probably way too big to graph. And I also have points at 4, -74, and -10, -74. But again, I probably won't bother fitting those onto my graph. But I definitely need to fit the vertex on my graph, which means I need to choose a scale that will allow me to go to 24. So I'll just sort of say that that's 10 and that's 20, because then 25 is right at the top, so 24 is a bit below it, and that'll do. I'll label this y, label this x. Now, in terms of making a good graph, because I labeled this axis, I need to keep labeling the vertical axis in a consistent pattern. And even though I'm going to use on the horizontal, I'm going to say that one box is 1. I'm still going to put some sort of scale on, just so that it's clear what my scale is. Because when you change one scale, you need to indicate whether or not you've changed the other scale as well. So there we go. So now I'm going to choose a different color so it shows up. And I'm going to start to put this stuff on. So we know we have an axis of symmetry at -3. So I'm going to use the tool in front of me to actually draw a perfectly straight line for the axis of symmetry. Oops. And then, again, use the tools I have to move it a little closer to -3. Hee hee hee. Come on. Yay. Okay. So there's my beautifully straight line. And then, what do I know? So the vertex is at -3 and 24. So right here. There is a y-intercept at 0, 6, so right about here. And of course, because of symmetry, this is 3 units away. So there's another symmetrical point, meaning exactly the same y value, 3 units on the other side of that axis of symmetry. And then I should be able to put this x-intercept at 0.50, and the other one should be at -6.50. And again, what you should notice is, if you take the axis of symmetry, oops, I did mess up, didn't I? Whew, probably yelling at your computers, Miss, you messed up. I know, I'm fixing. Okay, where was -6.5? -6.5 is right here. And it's a good thing I checked that, because what you should notice is that from one x-intercept to the axis of symmetry is 3.5 boxes, and from the axis of symmetry to the other one is also 3.5, because that's the axis of symmetry. And then I just try to draw, and it's really hard using the computer, a nice, decent parabola that goes through those points. Eek, here. Okay, really hard. But there you go. I'll live with it, and then I'll just label x equals -3 as my axis of symmetry. So there you go. That is kind of the fundamentals of working with a vertex form quadratic. And I just want to remind you, thank you for watching the video, but studying math means doing math. If you're just watching me do math, you're not studying. So open up a book, go and practice. Thanks for watching.